Let's be honest, if you've ever spent hours wrestling with messy code just to pull a few basic data points out of a PDF, you are absolutely in the right place today. Welcome to The Explainer. Today, we're unpacking a tool called Lift by Datalab. This is a fascinating new solution specifically designed to completely eliminate the massive headache of extracting structured data from those messy, unstructured documents. We're going to dive into the architecture, look at the performance numbers, and see exactly how you can drop this into your own tech stack.
Okay, let's dive right into this. Here's our roadmap for today. First, the unstructured data problem. Second, meet Lift and AI document extraction. Third, how it works with JSON schemas. Fourth, the benchmarks where it beats the competition. And finally, how to use Lift today.
Section 1. The unstructured data problem. Now, I want to ask you something, and I guarantee anyone who's worked in data engineering is going to feel their blood pressure spike just a little bit. Have you ever tried extracting specific data fields from a 60-page PDF? I mean, we've all been there, right? You're dealing with varying layouts, weirdly merged cells, completely random fonts, and you just end up writing endless custom regex rules while questioning all your life choices. It is a literal nightmare for developers.
The old way of doing things meant duct taping together fragile OCR, optical character recognition, writing those endless regex rules, and dealing with the sheer misery of aggregating data across multiple pages, highly error-prone to say the least. But Lift introduces a fundamentally new way. It uses just a single pass to read the document and outputs guaranteed JSON that perfectly matches your exact predetermined schema. No more broken pipelines just because a comma shifted to the wrong place.
Section 2. Meet Lift AI Document Extraction. So at its core, Lift is a 9 billion parameter vision model. That's the key takeaway here. It's relatively compact, but incredibly powerful. And because it's a vision model, it actually looks at the PDFs and images you feed it. It understands the spatial layout of the information instead of just blindly scraping raw text. And its primary promise? Simple, but a real game changer. It returns a valid JSON object that matches your schema exactly. Period.
Let's quickly run through what this thing can actually do. First, it extracts structured data seamlessly. Second, and honestly, this is huge, it handles multi-page documents in a single pass. You don't have to chop your PDFs up into individual images and run them one by one. Third, because it looks at the whole document at once, it easily captures values spanning across pages. Think about a table breaking over a page margin. That alone saves so much time. And finally, it's super flexible. You get two inference modes. You can run it locally on Hugging Face or run it remotely using a VLM server.
Section 3. How it works. JSON schemas.
Now, what's really interesting here is the secret sauce driving Lift. It's called schema-constrained decoding. Essentially, you're not just crossing your fingers and hoping the AI formats the extracted data right. You are forcing the AI's output generation to strictly adhere to a standard JSON schema that you provide. It's like giving the AI a rigid blueprint it physically cannot ignore. This means it is literally impossible for it to return invalid JSON structures. You will never, ever get a missing bracket or a text string where a number is supposed to be.
The workflow is wonderfully straightforward. Step 1, pass your document and a simple JSON schema to Lift. Now, a quick tip from the Datalab team, keep schemas simple to keep that output guarantee intact. Use strings, numbers, booleans, nested objects, but maybe skip complex logic like enum or any of. Step 2, Lift processes all those multiple pages in one go. Step 3, you get an output that exactly matches your schema. And get this, if a field you asked for genuinely isn't in the document, Lift doesn't hallucinate a weird answer. It just returns that field as a null value. It's so incredibly clean.
Section 4. Benchmarks. Beating the competition.
To really prove this works, Datalab didn't just test Lift on a few perfectly formatted grocery receipts. No way. They put it through a grueling 225 document benchmark with roughly 11,000 scored fields. These docs were anywhere from 6 to 64 pages long. But here's the best part. They intentionally planted highly complex adversarial scenarios to try and break it. We're talking cross-page values, exhaustive lists, fields that had to be left null, and near-miss distractors perfectly designed to trick the AI.
And this brilliantly illustrates the results. When scoring for deterministic exact matches against the ground truth, Lift hit a 90.2% field accuracy. Just look at what it's beating. Azure Content Understanding, a massive enterprise tool, scored 83.4%. New Extract 3 came in at 81.5%. Even Qwen 3.5, another 9 billion parameter model, only managed 76.3%. So Lift absolutely dominates this specific, highly demanding niche of document extraction.
But hey, accuracy isn't everything, right? Speed is absolutely crucial when you're processing thousands of documents. 9.5 seconds. That is the snappy median latency per document for Lyft when you serve it locally with VLLM on a single GPU. To put that in perspective, QN 3.5 took almost 17 seconds, and Azure lagged way behind at over 73 seconds per document. High accuracy combined with low latency, that is the holy grail for data pipelines.
Section 5. How to use Lyft today.
Getting started with Lyft is super flexible. You can use their command line interface to process single files or blast through entire directories with a couple of keystrokes. Building an app? Just use Python to load the model weights in process so you can efficiently reuse them. They've also got this fantastic Schema Studio. It's an interactive Streamlit app that lets you build, save, and visually test your schemas before pushing to production. And for the heavy lifting, you can spin up a VLM server via a Docker container that automatically scales its batch size based on your GPU's VRAM, whether you're rocking an enterprise H100, an A100, or even a consumer-grade RTX 4090.
Finally, let's talk deployment options. The Lyft model we've been geeking out over is available as open weights using a modified OpenRail-M license. This means it is completely free for research, personal use, and startups with under $5 million in funding or revenue. That gets you that awesome 90.2% accuracy. But if you're an enterprise needing the whole shebang, Datalab offers a managed API. That platform pushes field accuracy up to 95.9% and bakes in crucial extra features for high-volume batches, like per-field verification, direct source citations, and confidence scores.
So we've covered the unstructured data problem, Lyft's architecture, those incredible benchmark numbers, and how you can deploy it right now. I want to leave you with a final thought to chew on as you look over your own infrastructure. With guaranteed JSON extraction now running perfectly on a single local GPU thanks to Lyft, what fragile, legacy data pipelines will you retire first? Thanks for joining me on this explainer, and happy building.